Right, I'm really excited to be here today and talk about 3D printing. My own journey through 3D printing has only really been for the last about 3.5 years. So I'll talk about what drives me and about the RepRap project, which is a global project on 3D printing and self-replicatable machines. So I'll give you a bit of background of who I am first, why I'm here. For 20 years, I've worked as an electronics engineer in all sorts of different industries, designing products and developing electronics and complete finished systems for companies all over the world. People like Dyson, not that I want to name drop or anything, but all sorts of different people. So it's been very interesting. Probably for about the last 15 years, I've been using 3D printers to do professional projects, large-scale 3D printing projects, to do all sorts of things, from shower controllers to sort of making enclosures for showers and electronics, to all sorts of different things. So my experience with professional 3D printers is quite long, but a few things happened to make it a little bit more accessible to everyone. So I'll start with RepRap, and that's the self-replicatable machine. Now, this was a project started in the University of Bath by Dr. Adrian Bauer, and he started around about 2004 on this project, just as some of the really key patents in 3D printing were expiring. So 3D printing is not new. It's been around for 30 years or so, and a lot of the big companies had patents that last 25 years. So one of the deals you make with a patent is you can exploit it and make as much money as you can. After 25 years, it becomes public domain, and people can do what they like with the information. So Adrian put forward quite a comprehensive idea about creating a self-replicating machine. So it wasn't really originally thought about as a 3D printer. That was just the easiest way to produce a self-replicating machine. And Adrian put this forward to Bath University. Now, it was very difficult for Bath University to originally accept this idea, because the whole point about a self-replicating machine is that it can self-replicate. So it's very difficult to control. Once it goes out into the open, you can't make money off of it very easily, because anyone can replicate them. So it was a bit of a leap of faith, and in about 2004, Adrian managed to convince the university to allow him to put a lot of effort into making this a reality. So a lot of things had to happen between 2004 and around about 2007 for the first machine to arrive. The very first thing that happened is the university had already a very expensive machine, one of these very big machines under the expensive patents. They cost anywhere between £20,000 to £50,000, and he used that machine to create the first set of plastic parts that he could create his own 3D printer with. Now, when he did that, he immediately realized that he had to release everything as open source, because it becomes impossible to control. So that was the big step for the university, to realize that he was going to give this away for free. This wasn't going to be something they could make, on the face of it, money from. So Adrian spent a lot of time developing the hardware and the software and all of the structure around it to create the first machine. The first machine was called Darwin, and it was finished around springtime in 2007. The very first time they turned the machine on and had it all working, they wanted to print a part, and they realized that one fundamental mistake that they had made with the belts going around the machine that controlled how it moved up and down. They weren't tight enough. So the first thing Adrian had to do is hold a screwdriver against the belt for about half an hour while it printed a belt tensioner. So it printed its very own upgrade, the very first thing it did, because Adrian wasn't going to stand there for that long every time trying to print a part. So very first thing it did, printed a belt tensioner, pushed that on, and then it could effectively print anything with some things around that. So the project went on, and the files got distributed out to a very small collection of people that were working to make the project more accessible to makers and early adopters. Vic Oliver, he's based in New Zealand, but he was a close partner with Adrian in the early days, and he was the very first person to create a machine from Adrian's original machine. So Adrian produced a set of parts, sent them to Vic in New Zealand, sorry, and he produced a set of parts. What I've got to say here is that the whole point about Adrian's machine and vision is that this machine can be made anywhere in the world. So it has to have accessible parts. It can't have laser cut CNC machine panels or anything like that. It's supposed to have very simple parts. So Adrian's machine consists of mainly threaded rod, cheap threaded rod you can buy from any hardware store pretty much anywhere in the world, and parts that join all of these pieces together, and other bits of electronics which we can't quite safe replicate yet, but we're getting close. So after that, a number of different things happened. A lot of people got very interested in the technology and started using it, and that was about where I joined in. So I was watching it around 2009 when it all really sort of started to blossom into something you could pick up and run with. My first experience was the one on the left. I thought I knew better than everyone else, so I decided to make a machine that was really strong and using big chunky machinery and everything else. It was a total disaster. Well, it wasn't quite, but it didn't actually work as well as Adrian's machine. It was very slow, it's very clunky. It would have been great as a subtractive machining device, milling away parts, 'cause it was very strong, but it was very, very slow. So my first machine I did some experiments with, and actually all it did was let me produce the parts to build my next machine, which was a lot faster and actually based on the Mendel, which was over to the right there. I produced this one about 2010 to celebrate British manufacturing. I also developed a number of technologies and ways to produce more colourful prints. At that point, everything was just monochromes. It was just single colour parts. So my one on the left is not one of my first machines, but it's very close. It was around 2010. So the RepRap project has absolutely boomed all around the world, and pretty much everything you hear in the press about the low-end machines, the low-end 3D printers, all actually started from the RepRap project. Most of it is based on the project. The big success in America is MakerBot, and they're a big company selling a lot of machines now. That was actually a joint collaboration with the RepRap project when it first started. They split from the project. They still have some open source, but they have VCs to fund, so they have a few other things on their plate. There's lots and lots of machines now, and more come out all the time. The last count, about a few months ago, there was about 120 different variants of machines, and we can only guess how many actual machines are built and running around the world, but it's probably around 50, 60, 70,000 now. Some machines have gone slightly off of the RepRap direction and going a little bit further away from the self-replicatable element. That's mainly because of demand. People want these machines, they want them in kit form, they want to be able to build them up. So it's a little bit ironic, but we've actually some people have had to go back to mass manufacturing techniques to produce enough of these machines to satisfy demand. The machine I've got in front here, which is just printing, I'm actually not quite sure because I just pressed the button when I turned it on. So we'll see what comes out. But I think it's a pot. I'm not 100% sure. But this is called a delta printer, and it uses delta geometry to position the head. A lot of the other machines use what they call Cartesian coordinates. So the bed moves forwards and backwards, the head moves sideways and up and down. So you can position things in 3D space. Delta's just to look a little cooler, so I prefer those. That's also one on the left to produce some very, very large parts, like so. Okay, so how are they made? We've already said they're made of simple parts. Things are becoming more accessible around the world, so you can get hold of these aluminium channels now, which are really nice to use. You can buy them in Africa and all sorts of different places. So the RepRap project moves around with its goals, but really its still main goal is to produce as many of its parts as possible. So a lot of the parts are open source. Well, they're all open source, but they're all based on collaborative projects in the industry. So we've got the Arduino for the electronics. That's a very big project on the electronics side. It was one of the first open source hardware products. We've got standard off-the-shelf motors, threaded bars, and at the top there you can see a full set of parts. what I should have said on my previous slide, the reason why I made my very complicated machine was because it was very hard at the very early days to get hold of plastic parts. They were very expensive because people could charge quite a lot for them. So most people made their first machines out of wood, carved. They had to literally make all the pieces they needed to make the machine. So I chose metal and aluminium, but a lot of people couldn't get hold of these plastic parts. Now it's very, very easy. And for the first 2 or 3 years I was doing this project, most people bought a 3D printer to produce parts for another 3D printer that they could sell on eBay. That was really, really good way of getting your money back. And you can still do that. It's really good. You can print a set of plastic parts for about £7 and sell them for 70. So that is pretty good going. Okay, so how it works, basically we're using any type of thermoplastic. So we're melting a plastic into a chamber and squirting it out in a very controlled way using a stepper motor, which we can control in software very, very carefully. It's a very elaborate way of producing a product, really, to be honest. So it is quite a faff, but once it's all set up, it can produce things very, 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 very well and very uniquely. 3D printers have some really unique points that no other manufacturing technology can meet. So this gives you a little bit of an idea. This is the extrusion head at the bottom. That's how an extruder is made up. The filament gets pushed down and melted and pushed out the end. Everything has to move all at the right accelerations and at the right times. Otherwise, you just end up with a blobby mess of horrible plastic. So I've experimented with all sorts of different things, and it's one of the reasons why I'm known in the industry is because I've experimented with colours, blending and mixing and different materials. I've done ceramics, created an extruder that was very easy to put on machines that allowed you to put virtually any type of pastes, foods, chocolate. Chocolate is one thing that I get asked about every single week. I just get loads and loads of emails from people all around the world. It's a hugely popular thing. Everyone wants to print 3D chocolate. So it is really, really good. And there are some dedicated 3D chocolate printers coming out now just because everyone wants to do it. But it was good fun. I did that, I think it was a couple of Easters ago for the bunny down on the right. That's a white and milk chocolate bunny that was extruded out. The one in the middle is really interesting at the bottom. That's a wood. That's actually 40% recycled wood in a plastic laminate. So when you push it through the extruder, it melts the plastic, but also fuses the wood particles. The grain you can see on it, the different colours, is the different variance in temperature. So you can actually create grain effects with a wood filament. There's also now one that's just come out only last week that's got chalk powder in, so you actually can produce sandstone-like objects. And again, that's a chalk and a plastic mix, polystyrene mix. Really interesting. You can do all sorts of things. You can sand them, drill them, tap them, just like you can with a lot of wood and other parts. The one on the left is a masa, so that's sort of corn chips. That was really fun, eating them and printing them. My kids really like that. And there's all sorts of different things you can use: rubbers, plastics, nylons, and those. One of the other things that I've done quite a lot of work on is color printing. That's the next step in technology, really. And I've used various techniques. The one on the right is a layer selective color. That means that you're putting down one color and printing another color on the top. And where you don't have the two colors going over each other, you have the two different color effects. So great for creating flags and rainbows and various other things. Not so easy for creating really full color objects. The one on the left is more of a mixing and blending. That's still very early days, but that was using cyan, magenta, and yellow extruders all mixed together in one little chamber that could spit out any color combination. Still very, very early days on that, but it's getting really interesting. The more people that are working on the color types of printing. The other thing I've done very recently is used a nylon filament, which is really great. Nylon obviously can be dyed. It's just like the nylon you would have in clothes, so you can use normal clothes dyes to dye the color plastics to virtually any color you like. Feed them through the 3D printer and you get some really amazing effects. So this has been quite an interesting experiment for me, and it's generated quite a bit of interest around the world. Okay, one of the really important parts about 3D printing is that it can do things that no other technology can. So we've got some very simple things here, like the cube in a ball. the ball in a cube that would be very difficult to machine or make or injection mold or any other way. Because it's made up of layers built up over time, you can create very complicated objects. The ball of stars on the bottom is a very, very complicated object, would be almost impossible to make in any traditional method, can be made with a 3D printer. The one on the right is really interesting. There's a big collection of a database of all products that people can post for free for people to use, and I think it was this Valentine's someone posted this nice little box which is a magic heart box, and it turns around into a heart box that you can open and put things inside, and closes and locks together and looks sort of a secret little box. So this has got 8 different parts and all 3D printed and about 5 screws. So everyone thought that was absolutely fantastic. You can print that out and give it to someone you love in pink or whatever else. About a week after that, one very clever chap decided that he was going to take that idea and actually make it as a totally 3D printed single object. So this heart box is in essence the same, but it doesn't have any other components and you don't have to do any assembly. So this comes straight off the 3D printer. You literally just take it off and it opens up the same way. It's got the hinges all built on and it still works in the same way as the one that you had to build up. So that's the thing that makes 3D printing different from any other technical, any other way of working, that you can literally go away, have a cup of tea, maybe 3 or 4 cups of tea, come back and you have a finished part that's actually assembled that you can use straight away. There was no messing around with that. You see the top's still a bit rough where you could have sanded it off, but that was just literally off of the printer and used. So really, really interesting possibilities for 3D printing. The thing that drives me is the custom one-off design element of 3D printing, and it's really becoming quite important for the sort of maker generation, that a lot of these materials are quite cheap and quite easy to get hold of. The value is in more what it means and what it means to actually create. So I don't know if anyone has seen Ben and Holly's Little Kingdom. Anyone? Come on. No? Okay. It's a fantastic Channel 5 program that I watch with my 5-year-old. And, well, she's a bit older now, but when she was 5, we sat down watching Ben and Holly's Little Kingdom, and she said, "Daddy, can you make me a holly wand?" And I said, "Yeah, I probably can." This was 3 years ago, and I only just started. She was 5, and I said, "Yeah, let's have a go at that then." So being the good dad, I immediately said yeah, and went straight off to the internet to see if I could buy one. I couldn't, damn, so I had to actually make one. And we sat down one Sunday and figured out what a holly wand looked like. Don't tell Channel 5 this, because I'm sure they'll probably have some copyright issues, but I created a holly wand in the shape of a pencil topper. So the problem I had was my little girl, she's very ambitious in these things, and she said to me, "But I need it to twinkle, I need it to glow, I need it to rattle." I thought, oh my crikey, how am I going to do that with a 3D printer? So that was a real challenge. And a lot of my work, a lot of the things I blog about, I attribute to my kids. They come up with the most amazing ideas. And this was one of the very first things I did with my first 3D printer, with the layer selective color printing, and even throwing glitter into the printer while it was printing. That was just an idea because she said, "I want it to sparkle, I want it to twinkle, I want it to glow." So this one's made out of glow-in-the-dark plastic with a face, and it twinkles because I dropped some hammer beads in there while it was printing. And this one has got a similar thing, but I threw glitter over the printer, made a total mess, but at the end of it, it was a nice little glittery thing. My daughter was absolutely thrilled. The only problem was she took them into school. So that's a real big issue, because then she's going into school saying, "Daddy's got a machine in the garage that can print toys." Oh no. So there it all started, and I had to end up producing various little boxes and all sorts of other things. These are little party boxes that screw together. They slide and twist in. The kids really love them, but it's great because they think about ideas all the time, much better ideas than I could ever think of, and really challenge what I can do with 3D printing. So a lot of my stuff I really attribute to the kids, and this printer I've got here today, was actually designed and developed for my kids to use. They have a little menu system on there. They can actually go off and print the things that they like to print. It's that easy to use. It's the only one I was prepared to bring today because I knew I wouldn't have very much time to set up. So I knew it would just work, hopefully. Okay, so I'll try and go through this quite quickly because it's a little bit sort of techie, but the 3D printing process is really quite straightforward. It's not that hard. You can use free tools, you can use very expensive tools if you wish. The Rhinoceros software is something that's used a lot for people that do jewelry, so anyone that's familiar with jewelry might be already familiar with that. I use the free package SketchUp from Google. It's really good, totally free, and you can do anything you can see that I've done here today is all done on SketchUp completely for free. So there's online ones, Tinkercad, you can do that all on a website, you can develop all sorts of things, you can share all of your creations with other people and they can collaborate and do things with you. There's even ones for your iPad and your Android tablet that allow you to use your fingers to create all different types of creatures. This one's called 123D Creature from Autodesk. It's again a free app and it gives you a skeleton framework and you can go off there and kids really love it because they can pull all sorts of different creatures out of it. There's also a really great tool called Mesh Mixer where you can take off-the-shelf objects and mash them together and produce all sorts of strange things. So that object was those 4 objects down the bottom created that one. That's really easy to do. You just pull them together and it blends everything for you. So not particularly that difficult. So my object there on the right-hand side, I produced, exported out in a STL format, which any machine from 30 years ago, the big expensive £100,000 machines down to these machines today can understand. It's all described by triangles, so it can be scaled up a bit like an InDesign file rather than a JPEG graphic. It has full scalability, so you can print them at any size you like. You run that through what's called a model slicer, and that takes the program and slices it into set layers. And you can define how fine you want those layers. So they can be thinner than a sheet of paper, so sort of 0.1 millimeter. Usually around 0.25 is where we tend to use for sort of standard everyday objects. This was sliced at 0.3 if you're interested. It's got a little bit of a grain to it. Okay, so what comes out of that is a path that the machine can actually understand, and that draws effectively each layer and builds up the model over time. You tell it how much to infill, because we don't tend to make all of these parts completely 100% solid. It uses a lot of plastic, takes a lot of time, and you don't need to, because you can create really strong parts without it. So this was a 25% infill, very strong part, I needed it. You run through some PC software, or you can actually just put it onto a memory card in most of these printers and pop it straight onto the printer itself and press print. It's that easy. And there you go. That's what it ended up like. So very straightforward little part, but a mechanical part I needed for another printer. Okay, so I'll skip over a little bit of this because I'm probably going to run out of time, but a lot of the technology from 3D printing is, as I say, quite old. One of the first technologies I ever saw and was developed was called SLA printing. Now this uses a resin to produce the parts, and it uses laser beams to fuse the resin together. It's really good for very, very high quality, high resolution models, usually only small sizes, but absolutely fantastic for things like rings and jewelry. So a lot of people use these types of printers. And again, these patents are expiring as well now. So the one down the end on the right-hand side is about £2,500, and before they were probably around 20 or 30,000 for these machines. So it's becoming much more accessible, even for jewelry makers and people like that, to use this type of technology, just because all of the restrictions around the licensing and everything have gone. There's a few other technologies, I won't go too much into them, but they use different types of powders or binders to produce the same types of things. This one's, I will just quickly go over this one, because this is probably what we'll end up with on our desks in 5, maybe 10 years' time. It's basically, you can think of it as 3D inkjet printing. It's like your inkjet printer. It uses various types of materials that aren't just resins, so they're not just brittle like resin is. They can produce over 100 different materials in various softnesses for ABS-type impact-resistant plastics, completely clear, and they can all be mixed and blended together. So there's a ship and a bottle over there, and a flute, and they've all got different plastics, all blended together, and actually printed in one go on a 3D printer. So this technology is probably what we'll end up with. You can see that this hasn't done very much since I've been talking, and that's the reason why. This is very slow. That has the potential to be very, very, very fast, and that's what people will need in the future. I'm not going to explain laser sintering. I will talk about this one. This is really important for the aircraft industry. Direct manufacturing has a really massive impact in the aviation industry. At the moment, you produce a great big block of aircraft-grade aluminium or titanium, and you mill away normally about 90% of its value and of its mass. All of that waste can't be used for aircraft-grade aluminium again, so it can be recycled and used for other things, but it is a bit of a time-consuming and expensive process. What direct manufacturing does is produces a bit like a welding rod of the same material at aircraft grade, and actually produces the part by fusing, almost like a welding machine, the rough shape of the object. When I say rough, it's very, very controlled, and it hasn't got any holes, and it's absolutely amazing aircraft grade products. Down the bottom right there, you can see on the top bit where it's been directly welded and then slightly machined afterwards. So they go over it with a subtractive process to machine off the rough parts, and you only waste 1% of that that was put down, not what you started with in the first place. So you only have very, very tiny amount of waste. And for Formula One and aircraft, this is the technology they're using now to not only save time, but to do it very, very difficult things that you couldn't do anyway with subtractive milling and machining. This one's laminated paper. It's really odd, but it bizarrely works. There's one project that really got me so interested in the wider format of 3D printing, and that was the Solar Sinter project by Marcus Kaiser. And what he did is he created a RepRap machine and dragged it to the desert. There's a fantastic YouTube video of him lugging it out of this great big 4x4 and lumping it into the middle of the desert. And what he's done is he's taken the principle of layer manufacturing, but using the sun's energy. Now, if I would have explained powder laser-based sintering, this would have been a lot more impressive, but I didn't do that. Anyway, the fact of the matter is that this is using totally the power of the sun to absolutely sinter and melt sand in the desert, layer by layer, and produce objects. So you can't imagine the amount of energy it requires to do that. But he's actually produced a method that, fairly crudely at the moment, but could actually be used to produce objects from nothing more than just sand and the energy of the sun. You can use these types of plastics to do lost wax casting. It's been very successful, and a lot of people do this. So you can get very good results and produce metal parts even from a hobbyist type of product. So that's something I normally get asked about. So I just thought I'd put it in there. There's a lot of other newer tools coming out for digital sculpting, for pottery, digital pottery and things. This is a Leap Motion machine. It's being relaunched next month. It's about £50, and this is effectively a device that sits on your desk and monitors all of your fingers very, very quickly and very, very carefully. And it allows you to actually sculpt things in free space on the computer. So the example on the side is a pot. You can actually sculpt like a potter and have that interaction in a more meaningful way with an object before you 3D print it. So these things are becoming really, really fast, really, really accurate, and feel natural to use. So there are a lot more different ways of doing it rather than just using a mouse. At home I use a 3D mouse, which you can push, pull, and do all sorts of other things. But I'm really looking forward to things like this that allow you to just be a little bit more freeform and creative. On that side, another project that I know quite well, I have quite a few discussions with these guys, the Unfold Fab, based in Belgium, and they produce some of the most amazing 3D ceramic stuff. It's still fairly crude compared to sort of modern day ceramic standards, but it's again quite difficult, impossible shapes that you wouldn't necessarily be able to do by hand or by any other way. So some of these things they're working on the geometry and working out how best to produce clays that can not warp in 3D printing, and technologies to actually allow them to use all sorts of things on the printer. So that's a really interesting area, and it's becoming more and more popular. How am I doing for time? Okay. This is, I tried to put in a bit of a practical example of 3D printing, because once you get your 3D printer and you've produced a few sets of parts to try and pay for it, you end up thinking, what am I going to do with it? And that's usually when people ask you to do things for them. And I could have given you examples of fixing my toilet, fixing my Dyson washing machine, fixing all sorts of different boring things. But I put this one up because it was a friend of mine. I like scuba diving, and so does he. He bought a new digital camera, underwater camera, and wanted to use his slave flash. Unfortunately, the manufacturer wanted, I think it was $70 plus shipping, to ship a new lead to him to work on his digital camera. It's only an optical lead, so it only requires an optical signal. So he asked me whether I could do anything to modify his existing lead. So, yep, I chopped the end off, and then I had to do something. And produced a very quick 3D adapter, and that's the thing up in the top. That took me less than 10 minutes in SketchUp to measure on his device, on his camera, and produce, and then printed out three samples, because it was it's almost as quick to print 3 sometimes as it is to print the 1, and it worked first time. So I think it took about 19 minutes to print that. So within about an hour, he had a finished thing, and it was even color matched to his camera. I had a red that was identical. So he was really thrilled and delighted. It saved him a lot of money, and that cost probably about 7 pence in plastic. So not very expensive. Just my time to measure it up and do it. So that's some sort of practical idea about what you can do with 3D printing. Another thing that really excites me, and the thing that is more the point about 3D printing, is what people do with them. Not that they make them and they develop them, and that's what I tend to do. I tend to evolve 3D printing itself, but the people that actually buy these 3D printers and then make businesses out of them, very, very successful businesses, are becoming more and more and more and doing really well. And one that really inspires me is Katie Huckgrunt. She's fantastic. She's a set designer in the States, and she works on theatre productions. And she was trying to figure out a way of working out how she was going to plan theatre productions and objects in those scenarios and show people. So she bought a off-the-shelf 3D printer, a MakerBot printer, and started completely to learn everything about how to use it and how to design parts. She became so good that she's produced replica Queen Anne furniture for doll houses and all sorts of things. She's now got a company, Pretty Small Things, that sells lots and lots of these things online to people all around the world in all sorts of different materials and different sizes and different scales. And she did that just from the fact that she was really interested in doing that. She's very, very good at it as well, but they are fantastic parts. And she does share the files as well with people as well. So if you have your own 3D printer, you don't have to buy from her. You can print your own. Another interesting one is toys, puzzles, and games. I designed the one for my 3-year-old over the right-hand side that allowed her to do a bit of counting. And there's quite a few people around the world that are doing lots and lots of interlocking puzzles and various things. And they're really nice because they can be generated in the computer. You can refine how it all works and then print them out and sell them. I wanted to put this one in as a bit of a spin-off technology. This was recently up on a crowdfunding site, and it generated about $2 million worth of pre-sales, and it's effectively a handheld 3D printer. So it hasn't got the positioning system that the printer here is today. Your arm does the positioning system, but it feeds plastic in at the top and it squirts it out at the bottom, and you can create wonderful things with it, like the Eiffel Tower there and all sorts of different jewelry. And these things are $75, so not expensive. You know, the plastic for them is not expensive either. So the creative aspect of this is really wonderful, and it really captured a whole lot of people's imagination. A lot of people placed orders for them, and they're doing very, very well out of it. So something like that is a different spin on 3D printing, but a very, very nice creative product that people can use, and almost anyone can use. I did mention briefly about a repository for objects, and that's the one I use is called Thingiverse. It's a little bit strange, but it has pretty much everything you can imagine on there. You go on and type frog on, you've got a million different frogs you can choose to print, and you can adapt and do things. A lot of my work I put on there to freely give to people and allow them to change and adapt and evolve, and that's really, really quite nice because you see all sorts of people doing all sorts of different things. I put up an extruder. It's the little black one towards the top there. It's a peristaltic pump. Normally you would have that used in sort of the medical type of sector for pumping blood around people's bodies. I developed one that could pump around any type of liquid. And I put it up there and I actually said, I'm not going to do anything with it. I've just put the file up here. I had a small demo of me on YouTube just making it work by hand. Didn't even put it on the 3D printer. Within about a week, I had a guy coming back saying, yeah, I've printed it, I've worked it, and now I'm printing out T-shirts with ink. And I thought, wow, that's amazing. So, he had done something more with it than I did, even though I just developed it just for fun. Those sort of things are really good. Another guy emailed me to say, yeah, I'm using it. I'm potting electronic components with resin. So the 3D printer, he puts his different components on, and it goes over and it squirts the resin in just as amount how much it needs. Very simple, but again, he was nice enough to email me and tell me what he was doing with it. Am I okay? Okay. I know this is a lot taken, but you don't have to buy a 3D printer. I'm not here today to sell you a 3D printer, but they are very useful for prototyping and visualizing your designs. A lot of designers now use third-party agencies, and sometimes they use their own 3D printers to get a rough idea that everything's going to be okay, especially in the jewelry industry. It's nice to have your own 3D printer. You might actually print something at 3 or 4 times the scale to make sure all your detail's right, but then scale it back down, use one of these agencies to get it in any types of precious metals, ceramics, full sandstone, full color, all sorts of different things. It's not particularly expensive. And again, these guys actually have online shops that you can register up to. They do everything for you. If you put your design up there, someone buys it, you get 80% of the sales, and away you go. They do all the work for you. So if you're a designer, think about 3D printing your objects and putting them up on these types of sites, because you can make some serious money with not a lot of effort. Another one is iMaterialize. They do some really nice stainless steel and all sorts of different ceramics and things. I'll very quickly go over this because it's quite a nice story. Just at Christmas this year, one guy in the States, I could have told you anything about distributed manufacturing, about China and sending files over there and the wonders of the internet and everything. I've chose this one because it happened to me and my kids. And again, I'm driven by my kids. So what happened is, a guy in the States put up an idea that he was going to put up a printable advent calendar before Christmas. It was following the same advent that everyone else does, and he said, I've got a few things worked out. The tree at the presents at the bottom and the first row. So there was a couple of different objects down the bottom. But he said, then I need some ideas about what to put. So he uploaded the first few, and a few people printed them, and then said, "Oh, wouldn't it be nice if we had a TIE fighter?" There you go, some kids' memories coming back there for 30-year-olds and 40-year-olds. And there was all sorts of different suggestions about what could be printed. And over the period run up to Christmas, and on Christmas Day, he produced the star. My one's on the right-hand side. There was loads and loads of these, but it stands about 1/2 meter tall, so it's quite a big object, and it was really good. My kids were thrilled for Christmas, but they were more excited to come home every day to see what new part was being uploaded by this chap in the States to everyone in the world who wanted to print them, and actually decide what color we were going to do it. And he made them so they all printed within about an hour. So it was before bedtime. So I could set them all off, they could watch them print, put them together, go to bed, and then the next day do the same thing. So that's a real magic element of distributed manufacturing. There was lots and lots of different end results because everyone had different colors, different objects, different sizes. So some people change the objects as they get put up there because they didn't want to print them. And I changed a few, but it really is a good example of that type of interaction with especially with children that's made a real magic Christmas for us. I won't go too much into this, but there is a chap in Italy that's producing the most amazing 3D sculpted houses out of concrete, and he's a bit mad, and there's a film being made about him at the moment. It's called The Man That Prints Houses, and he's got great grand plans for printing all sorts of things. A bit like the guy that did the Solar Sinter project. He wants to use raw materials that are available and produce accessible homes for shelters and all that sort of thing. So he's got a few prototypes, and he's getting better and better all the time. There's also a project in Holland called a Kamer Maker, which stands, I think, means huge printer or something, room builder, that's what it means. And it's a big low loader that tips up on its end, and it is one of these RepRap 3D printers, but absolutely jumbo sized. And it goes around Holland and goes around Europe, and it prints off these great, wonderful structures. Takes a little while, but actually they use quite large filaments. They use a lot of plastic, but it can produce all sorts of interesting things. And they have gatherings like this, and they're just trying to make people more aware about big 3D printing. So that's one that you might hear about in the news. Another quick one that sort of really got me excited, and another example that only 3D printing can do, is reef restoration projects around the world. Scientists have been struggling to be able to create accurate reefs for a long time. They drop tanks and all sorts of other things, but they can't get all the intricate pockets that you have in a self-made reef. Only 3D printing can do that. Down the bottom there, just some examples of those early ones. They're about half a ton each, but they have all sorts of intricate pockets that fish and various life can go into, and that can only be done by 3D printing. Okay, I know I'm overrunning now. The Tiny is very interesting as well. There's a University of Vienna have produced a system very similar to the resin printing, but using 2-photon lithography. The object, the car on the right, top right on there, is only 290 micrometers long, which, if you look at my printer down here, it actually is producing something, is got a nozzle size of 300 microns. So that entire car could fit inside that nozzle. So it's a really sophisticated way of micro machining and micro engineering. Really clever technology. So that's one to really watch out on. Medical, we've briefly gone into that. I'll basically just say it's another example of where 3D printing really excels. The body rejects parts that have been machined sometimes. With 3D printed objects in metal that's been sintered, they have a slight porosity, and you can control that porosity, and that's a lot easier for the body to accept than it is a part. Okay, I really wanted to get to this one because this is really good. This is a chap in the States that's producing 3D printed prosthetic limbs, and he's a real inspiration. I'd recommend go and have a look at some of his videos. The one in the middle, the footballer, fantastic story. He lost his limb, wanted to carry on playing football, could do it, and had a normal prosthetic limb, but he always felt a bit of a stigma attached to being the only person in the team that had a prosthetic limb. He went to this company and said, "Can you do anything about this?" And it was one of the first ones they did, and they designed plastic 3D printed parts that could snap fit over his existing limb to make him feel more at home. And he has a whole set of these. So he has one for football, and he has one for going out for the shops, and he has one for everything else. And it's really great. Again, the lady on the left, she wanted one that was showing off her limb. A lot of people tried to hide them. She wanted one that was technical, advanced, and that's using all sorts of various techniques. The one down the bottom was really interesting. There was a chap, he had a really distinctive tattoo, and he lost his limb, and he wanted it back. So he asked them, how could he do that? They 3D printed parts, and they also made a leather covering to go over the front. So some natural materials as well as 3D printed materials that they could then laser etch his tattoo back on. So he got his tattoo back. Really inspiring stories. The guy on the motorbike, he wanted his limb to be part of the motorbike. So again, he's got that one. You can't really see where his foot joins and everything else. But there's some really wonderful stories. I couldn't put up the ones about children on there because I'd be in tears. I really could. So there's some really amazing ones. And last but not least, the fashion industry. There's a lot of talk in the media about 3D printing, a lot of hype, a lot of untruths, and all sorts of things. The fashion industry is the biggest hype machine in the world, but it does drive things. So there's a lot of beautiful objects coming out for fashion. I just wanted to mention the Dieter von Teese dress, which is on the right. That was in the press and saying came out of a 3D printer, when you read the press releases, you pretty much thought they pressed a button and it popped out. The reality of that is there's 300 separate parts, all produced in nylon that's very flexible and perfectly fitted to Miss Von T's body shape, but that all had to be individually stitched together. And it took months to produce that dress, but the press would let you believe that it was just 3D printed in 1 second and it's going to revolutionise everything. So don't believe everything you read in the industry. There's a lot of stuff about NASA and all sorts of printing on Mars. God knows. There's a lot of hype about 3D printing at the moment. The reality is, this machine in front of you for day-to-day use and for hobbyist use, and it does take a while. All that time I've been talking, it's got quite a reasonable way up, but it is taking quite a while to produce these objects. So 3D printing is going to get better, it's going to get faster, but at the point we're at now, it's really great for prototyping and more accessible. Just to give you an idea of the sort of costs, this sort of 3D printer would be about £400, so it's not particularly that expensive. And the materials to run them are about £20 a kilogram. If you look back on the 30 years ago, that was about £350 a kilogram for the materials, so very difficult to justify just for holly ones. I'll leave you reading that, but there you go. Thank you.